This final example on differential equations is quite a long one and fairly complex. I doubt that you'd be asked all of this in one go, but you should know all of the mathematics you need to actually solve the problem. So the growth rate of electric vehicles, which we'll call EV from now on, sales as a percentage P of all passenger vehicle, which we'll call PV from now on, sales in Canada, can be modelled by dP dt is equal to R P K minus P. At the start of 2011, which we'll call T equals 0, EV sales were 0.08% of all passenger vehicle sales in Canada. 3 years later, P had increased from 0.08 to 0.63%. The maximum expected percentage of EV sales is 72%. We want to express P as a function of T and then determine the percentage of EV sales expected at the start of 2024 and the year in which EV sales are expected to reach 50% of all passenger vehicle sales. This type of differential equation leads to something called the logistic model, which we're going to discuss briefly before we go ahead and solve the problem. In example 1 of this section, we discuss the fact that exponential growth cannot continue forever, at least not in regard to things like populations. This type of differential equation is known as the logistic model, as I just mentioned, and it gives a graph that's shaped like this, which has an asymptote. The growth is initially very fast, practically exponential, but gradually flattens out. And this is the type of thing that happens with many populations, that it will grow fast while there's plenty of nutrients and resources, but when they become scarce because the population gets too large, it will tend to flatten out. And from here, other things might happen, like a decline in population. One of the key things to note about this is the fact that it goes towards an asymptote. So along this asymptote, the gradient is virtually zero. In other words, dP dt is going to be taken to be zero, and that helps us find some of the constants. So let's go ahead and look at the problem. So we have dP dt is R P K minus P. As we move towards the asymptote, the gradient tends to zero. We just mentioned this. In other words, dP dt would be zero. This line in the question, the maximum expected percentage of EV sales is 72%, tells us that P tends to 72. So that's just given. But if we want dP dt to be zero, the only thing that can happen is for this bracket to be zero, and that tells us that K is 72. So that's why we can write straight away that K is 72 here, because K being 72, knowing that the maximum population is 72, gives us where dP dt is zero. In other words, where we head to the asymptote. So dP dt now is Rp 72 take away P. Separating and integrating, we get 1 over P, 72 minus P dP, is equal to R dt. Now these need to be split into partial fractions, or this fraction needs to be split into partial fractions so that we can go ahead and integrate. So they're both linear factors, so we know that we can split it like this, and then go clearer fractions by multiplying through by P, 72 minus P, which would give us this. If we take P equal to 0, this term disappears, and we get 1 equals 72a, so a is 1 over 72. If P equals 72, so that this term disappears, we get 1 equals 72b, which tells us that b is 1 over 72. So we can write 1 over 72 1 over p plus 1 over 72 minus p dp is equal to r dt. And we're now in a position to integrate. So I've got log p, take away log 72 minus p. Remember that minus comes from the differential of the inside function here of 72 take away p. The 72 here, I multiplied that onto the other side, so I get 72 RT plus some constant. Using log laws, we can combine these terms. So working from there, we can take the exponential function of both sides. We know that this 72 RT plus c, we can use an index law to split that into e to the c, e to the 72 RT, and then the e to the c is just a constant, which I've called a. Multiplying both sides by 72 minus p, we get this. And then expand the bracket on this side. And then the term with the p, we're going to take onto the left-hand side like so. And then we'll factorize the left-hand side. Then dividing both sides by this bracket, we now have an expression for p. But we may do some work with this expression before we move ahead. Let's divide the top and the bottom by ae to the 72 RT. So that's this part here. The top just becomes 72. This term obviously becomes 1 because we're dividing it by itself, and then we've got 1 over ae to the 72 RT. And I'm going to rewrite that as 72 over 1 plus be to the negative 72 RT. In other words, the b is 1 over a, and instead of having e to the 72 RT on the bottom, it's e to the negative 72 RT on the top of this fraction, which of course is on the bottom of the whole fraction. At the start of 2011, t equals 0, EV sales were 0.08% of all passenger vehicle sales in Canada. So 0.08 is 72 over 1 plus b. Remember, that's t equals 0, so the exponential term is just 1. So rearranging, we get this. And so 1 plus b is 72 over 0.08. And b is going to be 72 over 0.08 take away 1, giving us that b is 899. So we now have that p is 72 over 1 plus 899 e to the negative 72 RT. So we know that 3 years later p had increased from 0.08 to 0.63. So we'll substitute in that p is 0.63 and t equals 3. So multiplying both sides by the denominator here, and noting that 3 times 72 is 216, then we get that 1 plus 899 e to the negative 216r is 72 over 0.63. So e to the negative 216r is going to be 72 over 0.63 take away 1 over 899. So taking the natural log of both sides gives us this, and then dividing both sides by negative 216. And then we're just going to pop that into the calculator, and we get this value for r. So negative 72r is going to be this. And so we can say that p is 72 over 1 plus 899 e to the negative 0.6905 t. So in part B, the percentage of electric vehicle sales are expected at the start of 2024, or what we want to find is the percentage of EV sales expected at the start of 2024. We started in 2011, so t is 13. So all we do is substitute in and calculate, and we get 64.7%. Also, we want the year in which electric vehicle sales are expected to reach 50% of all PV sales. Well, based on this, we know it's going to happen before 2024, so that's a little check that we get this right. But what we're going to do is put P as 50, and then we're going to need to solve this. So 50 times 1 plus 899 e to the negative 0.6905t is 72. Divide both sides by 50. Subtract 1. Divide by 899. And then take the natural log of both sides. And therefore t is going to be this once we divide both sides by negative 0.6905. And if we calculate, that's 11.04. Remember, we started in 2011, so that's going to happen during 2022.